Hi all. Today we are going to see what an algorithm is and later we'll see what a flowchart is. Before moving to this session, I will explain about what a problem statement is in computer science. Think like you're working in a software company and if you want to develop a software in computer to perform arithmetic operations, that is a calculator. So here for the software engineer, the problem statement is developing a calculator for the computer. As soon as he develops this problem statement, he's not going to program the software. It's not going to do that. Before that, what he has to do is he has to do a lot of study and should identify the proper mathematical model which is required to develop the software. As we know, the software that we are going to develop here is the calculator. So in calculator, there are many arithmetic operations like addition, subtraction, division, multiplication, etc. Let us take the operation like addition. For addition, the operator that we normally use is plus symbol. And if you want to add two numbers, you will have an equation like a plus b or x plus y. Like that, whatever the equation that you formulate to perform an arithmetic operation, that is called as the mathematical model for that particular problem. In software companies, for developing softwares, they divide the problem into two phases, that is problem solving phase and implementation phase. The first step that we follow in problem solving phase is the identification of the mathematical model. Once you identify the mathematical model, this problem solving phase is again classified into two parts. That is, first one is writing the algorithm for that particular problem, and the second one is pseudocode. So what is this algorithm? Algorithm, it is the simplest way of representing the solution for the problem. That is, it is written using a normal English language. So if a third person other than the programmer who's doing it see that algorithm, he can identify what that particular problem is and what is the solution for that particular problem. Zero code is much more formal representation of the algorithm. It contains all the steps that you follow to find the solution of that particular problem. That is, it includes the mathematical model that you have developed for finding the solution also. Now we will see an example for an algorithm. Here in the screen, you can see an algorithm to find the area of the circle. And in this algorithm, you can see the steps. That is, everything that you write there is written as a step. That is a step number one. What you will do is, if you want to find the area of the circle, you need the radius of that particular circle. So you will be reading that radius of the circle from the user who's doing the program. Second thing that you have to do is, once you get the radius, you are going to calculate the area of circle. Third thing is, you have printing the area of the circle. You can see that the language that you use in this algorithm is normal English, and there is no mathematical representations or anything in this algorithm. So you first step that you do for problem solving is that you are going to write the algorithm for that particular problem. Now we are moving to the next step, that is a pseudocode of that particular algorithm. We all know pseudocode contains all the steps that you are doing to get the solution. Here we can see that the first step that you wrote there was start. Every pseudocode start with a start keyword and ends with a stop keyword. So that is what you have to write first. When you start the pseudocode, you have to write the first step as start, and the very last step that you have in the pseudocode would be stop. And then you can see the second step, that is reading the radius of a circle. Once you read the radius, next we can apply that radius into the mathematical model that you have created. So here the mathematical model is area is equal to 3.14 into radius into radius. So once you apply it, you will get the answer, and that answer would be stored in the area. Then you have to show the output, or you have to show the answer that you got to the user that has created this program. For so showing that, you have to print the area in the screen. That is, you have to apply the output to the output device. Then finally, you are going to stop the program. So this is how a pseudocode is written. So like that, you can write pseudocodes for all programs that you have. For example, if you want to add two numbers, the pseudocode can start with the start button, and then you have to read the numbers, that is the two numbers that you have, and then the mathematical model that you are going to use is adding those one, that is a plus b or b plus c is equal to d, and then you have to print the sum. Like that you can develop pseudocode for any programs that you write. Now we'll move to the next part, that is flowchart. Like algorithm, flowchart is another representation for the solution of a problem. Flowchart is actually a pictorial representation of the solutions or the steps that you are doing to solve the problem. That is, pictorial representation means it uses many graphical symbols. The symbols that we normally use in a flowchart are, for start and stop, you are using the oval symbol, and for input and output statements, the input output statement means you're reading something from the user and you're printing something to the screen, you use the symbol called parallelogram. So if you have any processing statements, that is the mathematical operations or anything like that, you're going to use the rectangle symbol. And if you want to check some conditions like a greater than b or less than b or like that, you are checking some conditions there, you'll use the rhombus symbol, and the arrow mark shows the flow of data from one step to the other. And connectors also we can use, and that I'll be explaining it later. Now you can see an example here. This is the pseudocode for finding the area of the circle that we have seen previously. In that pseudocode you have different steps. Each and every step that you see there is converted into flowchart. So you can see the start button, the start keyword, it's stored in flowchart, it is inside the oval symbol, and you're reading the radius, that is inside the parallelogram symbol, and you're going to do the process, that is finding the area using a rectangle there. Again, you're printing the output that you're going to have in the parallelogram symbol, and then you have the stop. So this is how you are going to draw a flowchart. So any pseudocodes or any algorithms that you write, you can convert the algorithm into flowchart that will show the flow of data from one step to the other. So that's all for today. Thank you.